Hello, everyone, and welcome to today's webinar, Pushing Passive, Affordable Housing Forges the Way for High Performance. My name is Miranda Wright, and I'm the Education and Engagement Manager at Illinois Green Alliance. You all have been muted upon entry, so please type any questions you have into the Q&A, and we'll get them answered towards the end. This webinar is being recorded and will be sent out in a follow-up email. For those of you unfamiliar, Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our five-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through educational events such as today with panels and building tours, by engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. Members can view our recorded webinars on our on-demand webinar library. And if you'd like to learn more about our membership or upcoming events, please go to illinoisgreenalliance.org. Next slide, please. I also want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, Resource Innovations, Sloan, and USGBC. Next slide. And for today, we have a great lineup of speakers. So first up, we have Susan F. King, FAIA, Lead AP and LFA, as a principal and housing sector leader with HED, a national multidisciplinary firm. As the housing leader for the Midwest, advocating for both attainable housing and green market transformation of the building industry has been a primary focus of her career. In 2013, she was the 18th woman from Illinois to be elevated to the National AIA College of Fellows. King is currently serving on two boards, the Illinois Housing Council and the Chicago Women in Architecture Foundation. She was also recognized by Green Building and Design magazine with Women in Sustainability Leadership Award in 2016 and by the University of Cincinnati as the Alum of the Year in 2018. Next, we have Tom Boeman. Tom is a licensed architect. He co-founded Boeman Design LLC with wife Susan Boeman in 2012. In 2016, Tom became a Phius Certified Consultant. Since then, Tom has enjoyed providing CPHC services on projects in the educational, single, and multifamily residential markets. He is president of the board of the Phius Alliance Chicago chapter and is committed to the advancement of the Phius standard and the adoption of passive building strategies across the building industry. And last but not least, we have Perry Vietti, president of Interfaith Housing. Perry has worked at Interfaith since 2002 and has been the president since 2016. He created and oversees the operations of 14 affordable rental developments to date, which includes 786 units. Perry previously worked at the U.S. Department of Housing and Urban Development in the Office of Community Planning and Development. Now I'm going to hand things over to Susan to start us off.
Yes. Yeah. Hi, everybody. Thank you. Thank you for giving us your lunch hour. And also first, thank you to Miranda and Katie Kaluzny and everybody over at Illinois Green Alliance for putting this together and inviting us to do this, because we've been anxious and excited to share our lessons learned on this project. Let me advance this. So the Conservatory Apartments is almost complete, and some of you will be joining us out there later on this afternoon. So this is, but I'm going to just quickly kind of place it for you for those who either are not from Chicago and are not coming out, or even for those who are. So it's on this slide, it is the red rectangular number 1 box is the site. So it's tiny, it's a tight site, and it sits directly north of the Garfield Park Conservatory, which is number 2. But it's a beautiful site, actually. It's on a boulevard, and it's rare to get to do an affordable housing project on a boulevard. So that's one thing. But the Conservatory Apartments, that's why it is named as it is. And it technically sits in Humboldt Park. The purple dashed line is an elevated rail rail line, and we're just north of that, and that's the division line between Garfield Park and Humboldt. And this, I'll just go quickly to the next slide. But for those of you before I do that, those of you coming out today, if you're taking the train, this is the green line right here. And so this elevated line, I believe it's definitely Metra. I'm not sure if it's also Amtrak, but those who are taking CTA would be getting off here. So it is actually a transit-oriented project, even though we did not take advantage, we didn't need kind of the advantages of that, given that we are single room occupancy, which we'll talk about quite a bit today. So sorry. One more slide here on Garfield Park and the neighborhood. Just for me personally, when there was a bright spot for me in 2020, and it was when Perry, my client, we don't do anything without our clients, called me to take a look at this site because earlier in my career, I spent a lot of time researching and actually writing about the Garfield Park structure and the neighborhood itself. And so it's a spot that I feel very passionately about. So I was delighted to have an opportunity to actually work in this crossing of two neighborhoods. And then also, as it became a passive house project really early on, to me, the juxtaposition of these two buildings next to each other does not, the irony of them does not escape me. So the Garfield Park Conservatory in its time was groundbreaking because of its transparent, it's a glass box. And then to be able to build today's kind of, working with some cutting edge, high performance strategies, making a kind of the opposite of the conservatory. So that's all another story for another day. But I wanted to mention it anyway. And so we've mentioned already that's a single room occupancy building, which means these are all studio apartments, and there's 43 of them. And the floor plans, as you see here, are pretty straightforward. And I'm going to turn this over to Perry with Interfaith to talk a little bit about their mission, why they do what they do, and who we're serving here. So, Perry?
Thanks, Susan. Hello, everyone. I'm just going to spend a little time actually going over 5 things real quickly. Mission would be number 1. Number 2 would be target. 3 would be, of course, cost. We always have to talk about cost. 4 would be the land, and then 5 would be incentives. So those are just 5 quick points that I'm going to hit. The first one is, who is Interfaith Housing Development Corporation? We're a mission-driven organization that's been around 31 years. Our mission is to develop and operate, and obviously preserve as well, affordable housing. And our niche really is special needs housing, right? People at 30% of the area median income. I don't know if that means much to you, but in the Chicago metro area, 30% of the AMI, as it's called, is essentially people at about $24,000 and below a year, a very low, income standard. And so most of the population we're serving are formerly homeless, special needs populations, mental health issues, substance abuse issues, various challenges. And this place is a place, obviously, where people can hopefully become stable and can heal. That's the whole idea. And this, I want to be very clear, this is not an institution in any way. This is a rental building. People sign 1-year leases. And the idea is they come here to have a permanent place to stay. There's no term on the stay, right? Like a shelter or transitional housing. This is actually permanent housing. Now number 2, let me talk about who we're targeting here. The target for the 43 units is broken down into 2 subpopulations and served by 2 different social service providers. I didn't really mention that Interfaith almost always does permanent supportive housing, which means services always blended with housing in some way. So, it's often on-site services, but really what we pride ourselves on is trying, again, not to make the building an institution in any way, but rather just a normal rental apartment building where services are provided through linkage agreements in the community, right? The community has all kinds of mental health and substance abuse and job training and benefits services. And what people need often is access to them, whether that's transit, whether that's having somebody help them get to it and, you know, navigate the bureaucracy. Sometimes it's part of all that. So that's the service provision that we provide. And for 34 of the units, we're targeting people that were individuals, right? Because these are all studios. So everyone here, this is not family units per se, it's individuals. So 43 of the units are going to be handled by Deborah's Place, and it's for formerly homeless individuals, people that have experienced homelessness that had some sort of disability. And that's can be all kinds of things. You know, you often think about physical challenges. It can be that. It can be mental health challenges. It can be substance abuse challenges. It can be all of the above, right? So that's who Deborah's Place is going to be serving on site. And we have service space that Susan has designed for them. Trilogy is the other service provider, a really strong mental health provider, just like Deborah's Place is a really strong organization. And they have 9 of the units. And these are folks from the state referral network. I'm not going to get into that much. It's basically just people that have been institutionalized, in most cases inappropriately, and there have been consent decrees across the state trying to bring them out of those institutions into the community with services, right? So the idea is for them to live in the community, not in an institution. So that's my number 2 point, is targeting. We're serving 34 and 9. 34 Deborah's Place, 9 for Trilogy. Let's talk about money, the 3rd point, cost. So how much does a building like this cost? $13.3 million, okay? It's a lot of money. And like in my world of affordable housing development, it's always the lasagna financing of many layers of money. So I'm not going to get into the nitty-gritty of that and bore you with how that's done. It's essentially, you know, the Illinois Housing Development Authority was the big player here, about almost $8 million. We have a loan from a bank, PNC Bank. The city came in with TIF funding, $3.5 million. And then we received a grant from the Federal Home Loan Bank of Chicago, almost $1 million. And then ComEd has a really nice energy incentive program. And this was their passive house pilot. So actually we were, I think, one of the first or the first for their pilot. And that provided some nice incentive money to do exactly what it is we're doing here. 4th, this land is a parking lot for a public school that closed back in 2013. So you may recall Mayor Rahm Emanuel, there was this process of closing a bunch of schools in the city of Chicago. I think the number is 58, if I remember correctly. This is one of those 58, and they were supposed to be redeveloped. This is just the parking lot, right? Right behind us is the empty school that's owned by somebody else. I hope someday we can redevelop that, but that's not part of the scope of this. So the land we got for free, which would really help make the budget work. And then 5th and finally, to the slide you see here, why are we doing passive? Well, one of the reasons is because it got us scoring points, right? You know, in my world, the funding is very, very competitive. There's never a given that you're going to get funded, no matter how great the project is. And IDA, to their credit, put this into the permanent supportive housing round, not the tax credit round, but the permanent supportive housing round that we applied for, I think 3 years ago now. And, you know, Susan and I talked about it, and she thought we could achieve this. And, you know, you see it's 10 points on that scale. So this is my segue now back to Susan to talk more about what you're all here to talk about, is passive house.
Yes. Yeah. Thank you, Perry. So yes, that is one of the key messages we hope to send out today, is that with an incentivization of 10 points, it was pretty easy for me to convince Perry to say yes to this. And so thank you for IDA for doing that. And I'm hoping that, you know, we are able to maintain that kind of incentives going forward, and also in the bigger tax credit QAPs. But so the path, what I want to say about the combination of the timing and everything else was the fact that I call it the new old code now, because it's 2024. This code is almost 5 years old. So just in numbers. But anyway, it had just been adopted in 2020. I believe it took effect. And so the key thing about the new code for us was the fact that it allowed us to build the project in wood, which would not have been allowed under the other the older code. And so what we saw was the opportunity to push passive, that there would be an economic strategy, or there was an economic strategy that said, because we're building in wood frame, we're going to save money, and we're going to take that money and we're going to get, triple glazed windows, the highest efficient system we can get for heating and cooling, the extra insulation. We think we can do this, sort of like trading off the structure for the envelope cost. So so we'll be talking a lot about what that meant and how that evolved over the course of the project. So so now I'm going to turn it to Tom to talk a little bit about the passive house strategy.
Thank you, Susan.
Yes.
I won't get too much into the details of the standard, but the project was certified to the Phius 2021 core standard. It's a high performance building standard, as I'm going to kind of assume that the audience knows. And it's a two-phase process. So the first phase is the design certification phase, which is based on energy modeling. That's pretty much what my role in the project was, to prepare the energy model and help advise the team on strategies to meet the targets. And then there's a second phase called final certification, which is based on on-site quality assurance, testing, and inspection. And that work is performed by the Phius verifier, which in this case was Echo Achievers. And that process is ongoing. They've passed a couple of key milestones, but there's still additional things before they get their final certification. But we are complete with the design certification. Next. Next slide, Sue. There you go. So the Phius standard is based on project-specific and location-specific targets. So the targets for every project are different, and basically you go online to this criteria calculator they have on their website, type in a few things about your project, the envelope area, the interior condition floor area, how many dwelling units you have, and it spits out some targets that you have to meet: heating demand, cooling demand, annual heating demand, and annual cooling demand, as well as peak heating loads and peak cooling loads, as well as something called the source energy target, which is kind of a reflection of how much total energy the building uses. And then we use this specific software called WUFI to model it, to verify conformance, compliance with the standard. And what we're looking for in this software is to get those nice green checks on the far right there that you see, meaning we passed all of our targets. And on this particular project, what'll be one of the themes is that we had a very difficult challenge meeting the source energy target, just because this is an energy intensive product type. And we'll see a little bit more about that later. And it did need to be offset with on-site renewables. So we did use on-site renewables on the roof, PV photovoltaics, and that got us down to just under our passing target on the source energy requirement. Next.
Yes. Hitting my buttons back and forth here. Sorry. Okay. Yes. So we also want to address cost early in this presentation, because that's what we always get asked sort of first out of the gate. And so this slide is actually information that Phius provides on their website. And it's pretty interesting, the case about the fact that we're a larger building, we're not a single family home, and some reasons why they believe that actually facilitates passive house. I don't want to say it makes it easier, because I don't think anything is easy, but maybe helps the situation. And then the bottom part, the rule of thumb for commercial and multifamily, that based on what they've seen for however many decades they've been tracking this, is that an experienced team can expect it, and this is talking about hard costs, not the full, the cost that Perry gave was total development cost of 13.3. But for this, we're focusing in on the hard construction costs. So they're saying an experienced team, someone who's been doing it a while, done it a lot, could expect a 2 to 3% increase. And then if it's your first time, you should expect 5 to 6%. And this is today. We've been very thankful to our contractors, Henry Brothers. We've been trying to put this together for a while, and finally this presentation gave us the deadline to get it done. And so big shout out to Henry Brothers for helping me with this. And these were our cost increases, broken out into the major categories that we think, that are specific to Passive House. And I have to say, even as recently as a week ago, when I threw the 5 to 6% rule of thumb at them, they were very, very nervous about this. So we were very, very excited when they came in, if you can read the slide, at a 5.8, just under that 6%, because for most of the team, it was the first time. And so, so this is pretty exciting. And also, but on second thought, because we just got this, the one thing I would add to this now is we did not include the renewable. So we are having a photovoltaic array that originally started out being, we had an allowance for it, and it wasn't part of the base bid. And initially, we didn't think we were going to need it. And so it became, so the building was designed as solar ready, and the PV was, we wanted to do it as a betterment if we had money left in our contingency. So as as everything evolved, when we found out we actually needed it, it was never officially part of our base bid. It was always an allowance, but we were able to pay for it out of our contingency. So the next iteration of this sheet, I would add that in. It'll tip it a little bit, but the other thing about photovoltaics and solar electric right now is there's so many incentives out there. Now, we didn't pursue those, but I would think other teams, if they needed to, they could. So then is it really adding cost if there's some other way to pay for it, is one way to look at it. And so now we're gonna get a little bit nitty gritty on the details of the exterior. And this slide is an evolution. So on the left was where we started, and that reflects that original economic strategy that we had, which was which included a really key thing was we seriously looked at exterior insulation finish system as the exterior face of the building. And the 2019 building code allows that, and they allow it on a project like this. And we had many conversations in that summer of 2020 and fall with Howell Hutchinson and all those, with the building departments, making sure that we would be allowed to use that material. And so so in that case, it was a pretty simple, I don't know if it's really simple, but a simpler foundation, and all of that on the left that we started with the wood frame. And so as you see at the end of the design development phase, that was when we submitted to the department, DPD and DOH, because of the TIF dollars. So originally it was sort of being viewed that IDA was the primary funder, so we didn't realize how much influence they were going to, or what say they were going to have on it because of the TIF money. So that's what the middle, that middle sketching, once we submitted, and a few things to clarify about this too. We were not a PD, we're not a plan development. We were zoned by right, and that was intentional on our part as well, to make sure that, just under the square footage that's allowed and all of that, because we were trying to simplify our process. But so the design, the committee on design had not really formed yet. So it was a little bit abstract, that process, I'll say that. But we did have to step backwards, because they were the ones who said, I think specifically DPD, but maybe DOH too, but we were handed down the message that we were not allowed to use the exterior insulation finish system. So we had to back up, and not just were we not allowed to use it, they really wanted us to do full height brick. And we were like, but we're Passive House, can we do something simpler? And so anyway, we were told to study it. So we studied it, and it mostly impacted our foundation, as you see in the next iterations, trying to figure out how to support brick without burying the brick as a good practice was the challenge. And then during that process of trying to figure out the brick veneer, because we were holding on to the wood frame, there was a rep who came in with, he was really coming in to show us thin brick options, but he had this product, a beautiful product called Coupa Clad, and it was a slate, and it's a rain screen. And so I was like, I wonder if we could do that instead. And so that is what ended up happening. You'll see that iteration in a minute. But from left to right on this slide, but I want to say for us on the design side for the first time, we really thought this is what we had to do. And we thought that, for a long time. And there was a lot of discussions with our structural engineer about, well, what is this insulation that goes below a footing that's supporting 4 stories? And they were looking at the insulation that's used for highways and all these things. And then finally we got to the point where we realized we did not need it to meet passive house. And so we were all happy it went away, and we got a savings at that part, at that juncture. So that's a lesson that people on the call that are doing a lot of passive house probably knew that, and we're like, oh, why didn't you know that? But I'm sharing that out for anybody who's about to do it. Don't assume, worst case for a larger building that you have to do that. Okay. And so Tom, so then he proved it out, Tom?
Yeah, so so it is a thermal bridge, and you do have to account for it, but it wasn't a deal killer. So we were able to, work with what it was. And so part of the role of the CPHC is to do these kind of analysis. So this is a therm analysis. It gives you the nice heat flow rainbow versions of Susan's black and white details. Then we do kind of a calculation that calculates what the impact of that thermal bridge is, that then gets incorporated in the energy model. And invariably, there's a few thermal bridges on every project that need to be analyzed. I think there are actually 5 total on this one, but most of them are kind of incidental. But they just have to be accounted for. And once they're accounted for and the model still passes, then you proceed. And sometimes you have to hit them a little harder. But in this case, we were okay with just that continuous insulation on the exterior of the foundation going all the way down to the top of the footing.
Yeah. And then we built it. So we can, so the way most of this presentation is structured is I'll show you the detail and then we'll show you the construction. Because those going to the site, it is almost done. So a lot of these things are closed. You can't see these anymore. But so in these views, you can see that the insulation's really there. So then in conjunction with all of that, then the verticality. So this set of slides is showing on the left, actually, before we did any WUFI modeling, these were our first passes, or that was one of the first passes at, what the building would look like. I think it actually, that kind of sketch got submitted in the initial application. And kind of, we're trying to keep the building simple because we knew it was passive house from the beginning. Also, our site didn't have a lot of room to do more than a box. But then between, in 2 months later, when we ran the first WUFI model, we then adjusted our elevations to help support a passing WUFI. And really, honestly, for HED, we felt like we didn't feel hurt by giving up some glass. We actually thought that simplifying the elevations was a good thing for the project. And then and it's still iterated after that, because you see on the right some of the glass that we took out in the middle, worked its way back in. And so like the community room, doing a punched, in a different way. So a punched opening instead of a ribbon glass, for example. And then it iterated further, because all of those were sort of looking at the extra insulation finish system into many, many iterations and plays with color. I just put 2 in, otherwise I'd have a lot more slides. So to how we, evolved then into the masonry veneer just at the base, and primarily the slate Coupa clad above, and then some areas of hardy type product for accent colors. And then I just want to talk a little bit about the windows and the view, and that's actually in the background of this is the view from the roof of the project. But the 3rd and 4th floors also have, they're looking out over Central Park Boulevard. You're going to have some pretty amazing views of downtown. And the one thing that didn't iterate was we picked an Alpen Tyrol series window way in the back in the beginning, and it's Phius approved and all of that. And that's one thing, you know, the elevation, the materials, all these other things changed throughout. The windows never changed. They were always the same all the way through. But then for the fun, I don't know if it's funny now, but when all of us, it was our first time with triple glazed windows, they showed up at the site and they had these little pouches on them, and we were all a little afraid of the wind. We were worried we were going to mess them up. We didn't know what, none of us had ever seen this before. So I'll just say it had to do with Alpine is a Colorado company, and so these windows apparently are made at a higher elevation than Chicago, and it has to do with the argon gas somehow making pressurizing them as they come into our altitude. And I'll defer all of that to, you're going to meet Aaron Riley from Henry Brothers in the field, and he watched a video. They were all really worried about that piece. So again, get installed. Taping. We're going to talk about taping in a minute. On the right there at the end of the day, windows are important. You know, it's the view, and there's going to be some pretty spectacular views for the east-facing residents of this building. So then framing, and you can kind of see some more of what's going on at the foundation in this, in the taping. And I want to just give a little shout out here to the subcontractor. So in some ways, I feel like we had a little bit of a hybrid team, because the subcontractor was is Edon, EDON, and they've done Passive House before. And I think it really, really showed. This was not, you know, it almost seemed like they just knew what to do, and they were great. And so, so I always like to mention that. So maybe we were a half experienced team, because also Tom mentioned Eco Achievers. Obviously, they've done a lot of this, and they were our rater during construction. So, where am I going? Yeah, it's all about the tape on some days. And then one other thing I'll say about this, nothing to do with passive, but and I hope I get this right. The green is the normal sheathing, and the brown colored is our shear walls. And then again, out to Edon and everybody, we were very nervous about our whole building test, one of the milestones within the Passive House certified process during construction, and we passed it. I guess with flying colors. And I think I posted about this, and this is actually, I think, what brings us here today. I think I posted this on LinkedIn, and that was when Katie and Green Alliance was like, hey, we need to see this thing. So so this was late summer, early fall, and you have to do the blower door, or this test, before you start all the cladding, to make sure that it really is as tight as it needs to be, and then that sets you up for success at the end. And then we talked a little bit about the photovoltaics. The image on the left, I was trying to figure out a way to visualize this, but I'll just say that we have the condensers with LG taking up quite a bit of space up there, and then we maximized like every inch that we could for PV. And so the image on the left is the array, but it didn't translate to my presentation very well. Tom, do you want to add anything here about that?
Only that we absolutely needed the PV to pass, hit the source target, and yeah, we maximized it. So that was kind of our hard stop. And yeah, just pointing out again, like you mentioned, the air source heat pump system, VRF system for the individual units, and the ventilation, is that the main ventilation unit right there? I don't remember what it looked like.
No, this right here is oh, I'm not sure. At first I thought it was insulation, but all the insulation's in.
But it's a rooftop ventilation unit, ERV system with VRF is kind of what the basic outline of the mechanical is. And so this is the only place to see it in this slide right here.
Yes, and then just a couple notes about the skin. So and again, because you won't, this is all closed up now, but so the base, the brick veneer, not really, kind of a normal detail. Although I will say our wall insulation was what I'd call hybrid. It was 4 inches rigid on outboard, and then BAT, which I personally haven't used BAT insulation in a project in a bazillion years, and I was sort of surprised ComEd let us do it. I thought we would end up with a spray like a rock wool and all of that, but this was sort of contractor's choice. We wanted to do it the most economical way, and I think ComEd allowed it because we could hold it. We didn't need it to be full, and that because usually the problem with that is they don't install it right, so you lose its thermal property when they don't cut it out right around outlets and things. But so we had room, the outlets and things sat in front of it, and then the insulation's behind it. So at any rate, the other thing I guess of interest, or that you always hear about with passive, all the thermally broken, the fiberglass connections, and so I mean it's kind of hard to see it here, but that's what this is, and that's what it's the thermally broken ties for the brick veneer, and you can see them better in this shot here, for those who have never seen those before. And then up above that is the Coupa-clad product, the slate, and this was actually I think contractor, or maybe actually was Edon's suggestion for cost savings. We had originally on the left supported the system similarly to how we were supporting the brick, with a thermally broken connection system, and they suggested that they wanted to know, could we instead use this night system, which is a continuous insulation system that's also thermally broken. And we could do that. We looked at it again, went back to the WUFI model, made sure that we weren't going to screw anything up by making that change, and then we were able to save money with that change. And we did it in shop drawings, we didn't update our detail. Okay, and so then just a couple more, just kind of layering it up, the pieces, and a summary on the R values, because we're always asked what was the increased cost, and then what were the R values again. So R60 at the roof, this combo of R20 and R15 in the walls, R8 under the slab, and then R20 at the foundation. And then I'll turn it over to Tom.
So in terms of how the building performed, these are kind of some of the reports we'll look at from the WUFI model. And one of the kind of good one to look at is the heating demand energy balance. Since we are in a heating driven kind of climate, this kind of gives you a good overall sense of where your energy is going to maintaining the building during the winter season. So on the left column of this illustration is where all your heat losses are, and on the right where all your heat gains are, and they have to, of course, balance out so that the building isn't getting cooler or hotter. But one of the things I want to point out about this is there's two kind of big blocks that are characteristics of this type of project. One is, you look at the cooling heat losses, a huge chunk of that is the ventilation. These projects, the SROs, are inherently heavy on the ventilation losses. That's even with an ERV. So even with an ERV, I think it was like 75% efficient. On this one, you still have a lot of heat loss through, bringing and conditioning that exterior air into the building for the occupants. And then on the right side, on the heating supply side, we have a lot of internal gains. This is just an inherently energy dense occupancy, and we'll see a little more slides on that. Next slide. So just to compare, since we are part of this ComEd program, they have a baseline model that they kind of give us guidance on how to prepare to compare how this project compares to a baseline of the same building. And so you see on the left here the ComEd baseline model, and then on the right, scaled down to be the same scale actually, how our building performed in terms of heating season heat losses and the heating demand balance. So we were really about a 52.4% reduction in the total heating season heat loss. So that's all because of the insulation, because of the use of the ERV, getting that extra level of efficiency in the envelope. Next slide. And then the other kind of useful kind of report from the WUFI model to look at is something called the site energy use. And this really gives an accounting for where all the energy use was used in the building over the whole year of the building. And you look at this, and this resulted in an EUI of about 33.29. And the top two are the ones you think of most for passive house, the heating and cooling, but they're a relatively small portion of the total energy pie here. You have a lot of energy that's for domestic hot water, which is third band down. Auxiliary energy fans, that's part of the mechanical system in a sense. But then when you look at large appliances, lighting, and and miscellaneous loads, which are the bottom three kind of bands there, those are not much different between the passive house project and a other kind of energy conscious, in the sense that they use maybe Energy Star appliances. So we have kind of a baseline of where your energy is going to fall. You can only get so far down. There's the 17 EUI is kind of a mythical thing on a project like this. It's just not. People need to plug in their refrigerator and have appliances, so you can only get so low. Next slide. Then if you did a similar comparison of this project versus the ComEd baseline model that we prepared, you can see we had overall about a 29.2% reduction in total site energy use from the ComEd baseline model. You can see a much bigger red block, so there's much more heating involved in that, and a lot more also in domestic hot water. But everything below and once you get down into the appliances, the electrical and plug loads and lighting loads, those are about the same between the two models. So it was really in those top bands, the heating and cooling and the domestic hot water, that we were able to make the most energy efficiency effort. And then this is just kind of a question that came up, and this is kind of a study that we did just as after the fact, actually, to kind of explain how this issue of having the single room occupancies work, and just to point out why it's an inherently energy intensive use. So what we try to calculate here is, if you just wanted to account for the energy used in the unit itself, for heating and cooling the unit, for the ventilation to the unit, but not taking into account corridors and common areas and so forth, but just accounting for what happens in that volume. If you looked at what the EUI would be for a typical kind of 3-bedroom, a 2-bedroom, a 1-bedroom, a studio, you can see that it goes increasingly up as you get into these smaller and smaller footprints. So the SRO, we would be up to a 39.3 kilobTUs per square foot per year. And that's, again, just for the unit. That gets diluted a little bit for the common areas, but it's almost twice as much energy density as you had for the 3-bedroom, which is only 21.5. So, it's just an inherently challenging product. So when you go comparing EUIs between your friends who are also doing multifamily projects, and you want to, this wasn't going to get down to 17. It wasn't going to get down to 20. It's just a very challenging product type. Next slide.
Yep. Yes.
So kind of the reasons for that, what drives all of that is two, really the ventilation requirements and the appliance density. So for ventilation, for any Phius project code minimum, you have a minimum exhaust ventilation of 25 CFM per kitchen and 20 CFM per bath. So there's a total of 45 CFM total that has to be exhausted from that unit. That has to be made up for with supply air. Typically, Phius would recommend 18 CFM per person, but you have to balance it. So we're providing 45 CFM per person. So when we're looking at a 3-bedroom, though, we would be down to like 72 CFM total, rather than the 45 that we have in the 1-bedroom. So again, we saw in the kind of energy budget that we're doing a lot of energy for just heating up this ventilation air. So that's why this product is inherently expensive, because we got a lot more ventilation per person than we typically would want or have to have. And also appliance density. Every unit has a kitchen, and a 3-bedroom still has just one kitchen. There's a few more people cooking, so there's a little bit more energy associated with it, but all of them having a refrigerator, whether or not they have 4 occupants or 1. So that contributes to an increased energy density just for that product type. Next slide. but on the other hand, Phius knows this, and they've modified the standard to actually make it possible to do these projects. And the Phius Plus 2018 version of the standard, which is what this project started under, there was a fixed energy target of 3,480 kilowatt hour per person per year. We'd have never been able to meet that. And when they developed the 2021 standard, they recognized they were not able to certify any of these products, and these products need to exist and they need a path to certification. So they modified the standard to actually make it possible. So our target on this was 8,125 kilowatt hours per person per year, which we just barely met at like 8034. So you can see that trying to meet the 3480 of the 2018 standard would have been effectively impossible. We couldn't have even offsetted that with photovoltaics because we didn't have a big enough roof. We would have had to make other kind of purchasing arrangements or some other arrangement for it. So this is just something that, Phius recognized, adjusted the standard because this is an important product and needs to have a certification path.
Yes, yeah, and so we talked about Tom has mentioned the ventilation situation, and that was definitely a challenge for us as well. And I guess I want to just we've mentioned lots of other people too. I mean, we decided to have 3 speakers today because we only have an hour, but there was also talk with Katie and Green Alliance about part 2 of this, where we could bring in our engineers who we haven't even mentioned at all, CCJM and Eco Achievers. The builder's going to be at the site today, but it's definitely a team effort. And in this case with the ventilation, we had to file what's called an ACAR, Alternative Code Approval Request. And again, those familiar with Passive House, and especially in Chicago, our existing or our older codes, that was always identified as one of the barriers and that has kept us from doing larger scale Passive House here in the city. And so we were able to submit this, and I had hoped that once we got done, it was very stressful, and I was hoping we were paralleling the adoption of the Chicago Energy Transformation Code adoption and taking effect. And so initially I kept saying that I think no one else should have to do this. No one else should have to go through this, that hopefully this will be code now, much easier, take that step off the table for other teams. But what we've heard this week, and I had heard recently on another Passive House project I'm starting, that's not true. You still have to do an ACAR. And so we tried to confirm that for this presentation. And I give kudos also. I want to give a lot of kudos to, in particular, Scott Farbman, who really has led the advocacy on this with the city to get this changed. And he even stepped in and helped us get through this. And but anyway, according to he was hearing the same thing I heard as of yesterday, that unfortunately teams still should prepare to have to submit this and go through this procedural. Hopefully it's just a procedural step. But this is, and I didn't know how to visualize it, so I just gave you guys exactly what we asked for. And then these are just some, we're almost done here, and we can do Q&A, some renderings of what the interior will be like, and another great view from the roof out there. I think that's from the roof this fall. And in conclusion, we can do this. It seems like a little bit like you're building a Cadillac, but why shouldn't we build better, and better usually costs a little bit more. It's true. So I think with that, Miranda, let me know how I do this. Do we just, I keep the slide up, or should we go to headshots or stop sharing?
You can stop sharing so people can just see us and our beautiful faces as we go through some of the Q&A. Let's see. Had brick been required, would it have been possible to accommodate the relieving angles without introducing a major thermal bridge or moisture issue?
I'll take that. That was our big concern, actually. That was so we ended up, I mean, you can always answer that with, you can do anything at a certain cost. Today I would, now that I've seen a lot of things being done in, I would look to the east, to New York City, because it seems like they're doing a lot of really tall, large masonry and what I call like the more traditional masonry cavity walls. But I think they may not have to have the relieving angles in that case because it's CMU and brick. So we didn't solve that because we were able to get them to accept the Coupa clad. So I don't have there might be a way, and I don't know if Tom sees a lot of
Well, yeah, I mean, we
more
have seen a
projects
little
than me.
bit, and it does result in thermal bridging, and again, it's like the one at the foundation. Well, is it a deal killer? You'll have to find some other way to make up for it. So it might have been 6 inches of insulation instead of 4 behind it. So there's little trade-offs you can do. It is challenging. I mean, you can't just run a horizontal steel angle that penetrates all the thermal insulation on the continuous thermal insulation on the exterior. You'd have to do some detail where that's offset with stainless steel bolts on one of those fiberglass pads. So we can do things to mitigate it, and then it's running the numbers and working it till it works. So not to
Great,
say a
thank you.
brick wouldn't be impossible.
Was there debris below the parking lot that needed to be mitigated prior to excavation?
I'm going to let Perry back me up on this, but I think the answer was no. We were lucky in that regard. It was a pretty clean site, right, Perry? I think it had always been a school.
I think the overdig on this development was the smallest one I've ever seen. I mean, it was a parking lot and never had there been a building there. So there was no urban debris or anything like that. So.
Great. Would a move to heat pump dryers made a noticeable dent in large appliance energy use or negligible for multifamily?
I'm going to let maybe Tom answer that, but I'll use this as an opportunity because we didn't say it earlier. We're, to use Perry's term, we are electric centric, but we do have gas for the dryer. No, the dryers are electric, right, Tom? We went back and forth on that 100 times. We have a little bit of gas here.
It's been a little while since I
But
And it's
hot
for
water
the
system, right?
component.
Hot water is gas, right?
It's the domestic
Hot
hot water.
gas, and I think
Yeah.
actually some of the reconditioning of the ventilation here is actually a gas furnace. I don't know what it would have helped. I don't know what the magnitude of that is. I really couldn't tell you. I don't think it would have been the deciding factor between the certification or not, but it would have been an improvement. Brought it down a little bit.
Let me just add that we don't really, we're using commercial laundry companies, right? We don't run our laundry rooms, so we have to use what they have. So, I would suspect they don't have that technology, at least not yet.
Understood. Does the building have backup storage from solar generation?
No. We wouldn't have had room for it.
And it's probably not that important on a building like this because you do have coincident use almost all the time. So it's highly, most of that electric up there is getting utilized on site. If we tried to go net zero, then it wouldn't be used. It'd have to be off stored or sent off site.
Yeah, and if I can just add on a little bit about the domestic hot water. So in 2020, it doesn't, I know it's not that long ago, but that's interesting to me because I feel like the projects I'm starting today, having the domestic hot water be electric seems to be less of, people are, I don't want to say afraid of it, but there seems to, either the market has caught up, it's not a big debate anymore where our engineers had not done it before. There's actually a lot of there was concern, and I learned that this was code actually about the delivery of the hot water to the user. That's actually a code requirement that it has to be there within a certain amount of time. And this, certain populations might be fine with that you can educate and be like, we're doing this for the greater good, and is it okay if you wait a few more minutes than normal for your hot water to come? But what didn't seem the right demographic population for that as part of it. Or another way to say it was Perry and his partner Harriet didn't want 500 calls. My hot water is not working.
Exactly.
The success of high efficient building systems depends so much on end user behavior. Because these are very different to operate from conventional systems, how do you account for efficiency loss due to end user behavior?
I don't know that
You don't.
I don't know that, well, either you don't, but I don't know what we have here that they can
Yeah, it's,
mess up.
Plug in lots of heaters in their units all at
Yeah,
the
I
same
mean, yeah,
time,
you
you
could
know,
have
like
somebody who-
unrealistic
Yeah.
things.
opens a window and you could have a lot of behavior that, so, I mean, that's not we're trying to make that's impossible to really account for, except to the extent that when averages are put to the occupants' use, which is something that is developed, we just kind of use averages for plug loads and so forth. Hopefully those evolve over time to be more realistic of reflecting of user behavior, but there's nothing in the design you can do because, this is not about manipulating people's behavior so much as providing an effective and energy efficient building. So
yeah, the behavior is
limited
gonna
things you
be
can
in
do.
any building, right? I mean, my
Yeah.
son had his window open on, a -20 day the other day. I'm like, what? So this is just, it's human behavior.
Yeah, yep,
That
agreed.
enter any model of building.
Were the condensing units on the roof 1-to-1, or were there any combined to supply more than one unit?
They were 1-to-1, but I think that's maybe, I don't know if it's unique or not, but because it's studios, they were 1-to-1.
I've had some questions about cost. At the beginning, Perry stated the 13.3 million. Is that the total construction cost?
No, that's the total development cost. That includes what I'm paying Susan King. So it's a total at 10.8 million is the construction cost.
Gotcha, great.
Yeah. What did you said 10.8, which I think matches my slide.
10.8,
Yeah.
and contingency will bring that up, right? It
Yeah.
will be over 11 by the time all is said and done, so.
Think that is the majority of our questions. I know we're almost at time, so I want to thank all of our presenters today. This was fantastic, and also excited to see the 40 that were able to make it and sign up for the tour. I apologize that the tickets are sold out for anyone who didn't make it, but thank you again, everyone here. And for attendees, we'll be sending out resources, maybe answering some of these last minute questions, as well as sending this presentation. So thank you all, everyone. Have a great day.
Thank you.